The Indian Army is currently on the verge of a historic breakthrough that will make it the very first military force in the world to operationally deploy 155 Ramjet-powered artillery shells, a technology that effectively turns a standard howitzer into a long-range supersonic missile launcher. Developed in a landmark collaboration between IIT Madras and Munitions India Limited, this new ammunition has already cleared developmental trials at the Pokhran ranges and promises to double the striking range of India's artillery from the standard 30 kilometers to over 60 or even 70 kilometers. This is not just a minor upgrade, it is a fundamental disruption of modern warfare that erases the traditional safe zones Pakistan and China have relied on for decades. By integrating jet engine technology into a standard artillery shell, India is solving the biggest problem of border defense: how to hit deep enemy targets without the massive cost of cruise missiles or the political risk of sending fighter jets across the border. To understand why this is such a game changer, one must look at the simple physics of a traditional battlefield. For the last 40 years, the range of a standard 155 shell, essentially a heavy bullet packed with explosives, has been capped by physics at roughly 30 to 40 kilometers. Friction slows it down and gravity pulls it to earth. This created a strategic reality where enemy supply depots, command centers, and reserve troops parked 45 kilometers away were mathematically safe from Indian guns. To hit them, you needed expensive rockets or airstrikes. The Ramjet shell shatters this limitation by cheating the physics of flight. It is a breathing projectile. When fired from a gun like the K9 Vajra or Bofors, it starts like a normal shell, but once it hits supersonic speeds, an intake opens up, sucking in oxygen from the air to burn onboard fuel. This turns the shell into a self-propelled jet that accelerates mid-flight, allowing it to glide at Mach 2 speeds for double the distance of a normal round. The tactical nightmare this creates for India's adversaries is hard to overstate. In military terms, this destroys the concept of strategic depth for the enemy. If a Pakistani armored division is assembling 60 kilometers from the line of control, they are currently safe from Indian shelling. They can fuel up, plan, and rest without fear. But with the induction of Ramjet shells, that safety evaporates instantly. Indian artillery batteries sitting securely in their own territory can now rain precision fire on these deep targets. It forces the enemy to push their logistics hubs back by another 40 kilometers, stretching their supply lines to the breaking point. Every truck carrying ammunition to the front now has to drive twice as far, burning more fuel and facing more wear and tear simply because Indian shells can now reach out and touch them from distances that were previously impossible. Perhaps the most brilliant aspect of this innovation is its plug-and-play configuration. Usually, achieving a 70-kilometer range requires buying entirely new massive rocket systems like the Smerch. However, the IIT Madras design is built to fit inside the barrel of the guns India already owns. The same Ramjet shell can be fired from the 30-year-old Bofors, the Indigenous Dhanush, the tracked K9 Vajra, and the ultra-modern M777 lightweight howitzer. This means the Indian Army does not need to spend billions on new launchers. It can simply ship these new crates of ammunition to existing units, and overnight, a standard artillery regiment is transformed into a long-range strategic strike force. This backward compatibility is a logistical masterstroke, allowing for rapid deployment across the entire border, from the deserts of Rajasthan to the mountains of Ladakh. The economic logic behind this development is just as powerful as the military one. In a prolonged conflict like the one we are seeing in Ukraine, armies run out of missiles very quickly because they are complex and cost millions of dollars each. You cannot use a BrahMos cruise missile to destroy a simple truck convoy. It is a waste of money. Ramjet shells bridge this gap. They offer the range and precision of a small missile, but at a cost closer to that of an artillery shell. This allows the Indian Army to use saturation fire on distant targets. Instead of firing one expensive missile and hoping it hits, they can fire a dozen Ramjet shells covering a whole area with explosives. This capability to sustain heavy long-range bombardment is what breaks an enemy's will to fight. Furthermore, this technology is uniquely suited for India's specific geography. In the thin air of the high Himalayas, jet engines usually struggle, but Ramjet projectiles actually perform exceptionally well because there is less air resistance or drag lag at high altitudes. Firing these shells from mountain peaks in Arunachal or Ladakh could theoretically extend their range even further than 70 kilometers, allowing Indian guns to target Chinese infrastructure deep behind the mountains that was previously thought to be out of reach. When paired with India's NAVIC satellite guidance, which these shells are expected to use for precision, the error margin drops to mere meters. India is not just building a better bullet, it is building a cost-effective, mass-producible sniper round for its heavy guns, proving that in the modern era, indigenous innovation is the most lethal weapon of all.